Earlier, you built a model of a rotational mass damper system where the mass had an initial angular velocity. If you were solving these equations by hand, or in Simulink for that matter, you would need to plug in an initial condition. But Simscape determines the equations for you, so where do you set the initial conditions? Simscape will actually calculate those for you as well, based on target values that you set. You can specify beginning values using the Variables tab of each component. Let's go back to our rotational mass damper system to see what this means. Here, the damper and inertia are connected, so realistically, they can't have different initial angles. If, for instance, we set an initial angular velocity of 10 radians per second on the inertia and 0 on the damper, that wouldn't make a lot of sense. But Simscape will still try to satisfy both requirements, in this case, yielding an initial angular velocity of 5 radians per second. The simulation is still accurate. This is the response for an initial angular velocity of 5 radians per second, but it's not quite what you expected. So, in situations like these, set the initial angular velocity on the damper or the inertia, but not both. If your model is more complex, it can be difficult to determine when a conflict might happen. But that's okay. As you just saw, Simscape will try to achieve as many of the requested values as possible. This does mean that the actual initial values used might differ from the requested values. To verify the values used, you can open the Variable Viewer, accessible from the toolstrip, or do a quick check by inspecting the simulation results. Remember, initial values different from your targets doesn't mean the simulation is wrong, just that the initial state couldn't be defined exactly as specified. If a critical initial value is not being met, consider which other initial values you might not need to set. In the next practice activity, you'll explore setting initial values and see how they affect simulations.